I don't know that this is on the test any longer. It used to be on the test, and so I always show people this because if they ever see it, at least it's not foreign to them. You may get a problem that has something, I'm trying to remember the problem they used, but it was like 9 to the 3/2 times 4 to the, I think it was maybe 9 all the way across, because you have to have the same bases. 9 to the 7/8, something like that. And they ask you, what's the answer? And you look at that and go, I have absolutely no idea. So what you want to think about is, what do you already know? And maybe you know this and maybe you don't, but now you'll know this. The square root of x can be written in a different way. It can be written as a power. The square root of x is the same thing as saying x to the 1/2 root, 1/2 exponent. The cubed root of x is the same as saying x to the 1/3. The 4th root is the same as saying x to the 1/4, and so forth. The 8th root is x to the 1/8. Where do roots live? Roots live in the ground. So our number's on the bottom, because roots live in the ground. So square root is a 2. We just don't see that 2, but it's there. It's like that invisible thing. There is a 2 there. This is 1/2, 1/3, 1/4, 1/8. So if I had the square root of, if I had the 3rd root and I said I need the 4th root, so I had the square root of x to the 3rd, or I want to say the 4th root of x to the 3rd. I'm going to rewrite it by saying x, and I know because I have this root that I can write it like a fractional exponent. Roots go in the ground, so you always put in the ground first, plant it first, then put your exponent on top. So this is the same as this. So if you know that, now you can reverse it and go the other way. And they actually, I think, may have given us that on the problem. So you would have 9 as your base. It is cubed, and I need the square root of it, times 9 is your base, and I need the 8th root of it, and it's to the 7th power. I think they gave you something like this on the test. And then they ask you, well, what's the answer? So first thing you're going to do is write it like this. You write it, put the base down, make a fractional exponent, put your root in, which we know that if it doesn't have 1, it's a 2. 3 goes on top. And we write this, because I think that was the direction they gave it in. They gave it to you like this and asked you what's the answer. And the answers looked like this. So, and I don't even remember now if they had a number. But what you want to do is you want to think about, what do you know about exponents? And you think, oh, this is just an exponent. It's a funny looking exponent, so it's going to freak me out a little bit because it's a funny looking exponent. But I'm going to go, well, I'm going to make a baby one. If I have x to the squared times x to the 3rd, what does that mean? Well, it means I have x times x, and it means I have x times x times x, which means I have x to the 5th power. That's what that means. How do I get 5 with 2 and 3? I add it. Oh, that's right. I add my exponents when my bases are the same. So you're going to do that. 9 3/2 plus 7/8. Now, when I tell you there are no fractions on this test, I mean there probably are some fractions on this test, but they're going to be this is a fraction question. You're adding fractions. So you do have to understand how to find common bottoms in this case. So if you would get a calculator, you can certainly use your calculator, or you can just go, okay, I have 3/2, and I have 7/8. My common bottom is 8. I raise this times 4. I get 12/8 plus 7/8, so I have 19/8. So my answer is 9 and 19/8. If this could have been reduced, if I could reduce that fraction, I would reduce it. but it can't. So that is actually the answer to this one. So just know that, I don't know, they took this off. I think they may have taken this off the test, but if they did not, I want you to at least, I didn't want it to be a foreign thing you've never seen before. You can go, oh yeah, she showed us that one day. So just remember that a root problem can be written like a fractional exponent. And if it has a power on it, then you put that on top. So as this one has a power, it's written like this. This one has a power, it's written like that. Roots live in the ground. They go on the bottom. Then once you get it in that form, if the bases are the same, you can add the exponents when you multiply them. If you cannot remember, you go back and make one to remember the rule, because you are mathematicians and you can figure out the rules. So you know how all math works the same. The things you learn in basic addition and subtraction is what we do later on. So that's all I have for complex roots. Somebody turn me off.